All right, it is day 22 of Advent of Code, and yeah, here we go. Okay, this is not a grid. Snapshot of bricks while they're falling. It's a position. Okay. Single straight line of cubes at integer positions above the ground. Which means that they could fall non-integer positions, but are we going to need to stack them or something? Some bricks will still be in the air. You're going to start figuring out where they will end up. They never rotate. Yeah, okay, that's fine. Yeah, I think we just stack them all. Right? Oh, geez. Trying to visualize a 3D perspective like this. Okay, so I think what we'll do, we'll need this, and then I don't think they have any names in the bricks or anything. Looks like no. Okay, and the locations. Yeah, so I think we just like make everything fall, right? And these are X, Y, Z. Which direction do they fall in? Z is the vertical direction. Okay. Ground is at Z equals 0. Lowest Z value is therefore 1. Okay. So what we'll do is just simulate them, I'm pretty sure. These are small enough that we can, how many are there? Okay, there's a good number of them. Okay. I think what we'll do is we'll just do yeah, so we'll just like loop through and then simulate everything falling. And to simulate it falling, we just need to check, can it fall? So if so we need to check every location below this. So the X and Y coordinates are all for X in range, X6. Do these need to be, let's normalize this so that it's like, okay, I really gotta make sure not to typo anything here. YZ, 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 YZ. Okay, I think that might have been unnecessary, but just in case. And now what we do is, we could just do this. I think we only need to simulate the lowest Z. Yes. So now the question is X, Y, SZ minus 1, solid. And what we'll do is if z is equal to 0, true. Otherwise, if x in range I think it's just this. We use the current bricks x, y, sc minus 1 if it is solid. And if we're supported anywhere, then we don't fall. And the way we do that is we just do this. I think we do that, and then the question is, let's just print how long they fall for. Okay, they're falling for quite a while here. Oh, I guess this is just really slow. I guess that's to be expected. This is like kind of n squared-ish. Ugh. We could keep like a full set of coordinates, but I think that's too many. Maybe it's not. These bricks seem kind of small. Yeah, well, why don't we produce this? So in that case, we just do if x, otherwise return x, y, z in b set. And then what we'll do is at the beginning, we will produce a b set. And we will I think we just loop. Nothing can ever be supported on anything other than the top z coordinate. So I think we actually only need to do this. Ez. These are all inclusive. Yes. So I think now we have the b set, and then this just becomes like this. Okay, that's a good bit faster. And it takes 308 for them all to fall, and then let's look at the first one. What? Well, that is clearly an issue. Otherwise, so if it is supported, then the brick just goes as is. Seems fine, maybe, hopefully. Not much we can do about that. Okay, so the question is, safe to disintegrate if after moving it, no other bricks would fall further directly downward. Only that brick. Oh, okay. Can I just hijack this? I think hijacking this is the best way. We just do like simulate around without that brick. And so let's do make bricks fall. This will take in a bricks, and it will just return a new. So it will return the new bricks and fell. That seems right. And what we can do, so I have my bricks. I'll do fell bricks equals bfall bricks. And I think that should just work. So this should, yeah, it still takes 159 for them all to fall. But now what we can do is we can do How many bricks could be safely chosen? Okay. So I know this is terrible. Wait, let's just do, okay, sure. If default be copy 2, if nothing falls, I think. Oh, I didn't print my answer. 439. Rank 4. That's pretty good. We use this chain reaction. The best brick to disintegrate. For each brick, determine how many other bricks would fall if that brick were disintegrated. Okay. This is gonna be kind of slow, but I have an idea for this. I think it should be fast enough. The number of other bricks that would fall as a result of disintegrating each brick. Yeah, so basically, because I wrote this in a crappy way, we need to like keep going until everything stops falling. So what we'll do is, so we've now deleted this. My code is awful. And now what we'll do, so the bricks do maintain their ordering, is nice. So what we can do is while not, or fell, false, true, fell, b copy 2, b copy 2, and then when we're done, we can check the number of bricks that do not match between b copy 2 and b copy 3. And now the question is, sum of the number of other, sum, okay. I think this is gonna be pretty slow now, so, but maybe still fast enough. Hopefully, I can always break out the PyPy if I have to. I probably should have had it open, but I do not. And it will take me a fat second to open it. Actually, what I want to do, there's the answer, 435.6. Rank 2. Wow, okay, that is a good day. Rank 4 and rank 2. I'm pretty happy about that. Whew, man, did not need PyPy. I wonder how close I was to number 1. I was 5 seconds. If I had the PyPy, I would have had rank 1. That is so sad. Oh man. Oh wow, it's crazy. This is the first time I've looked at this leaderboard for like one day, and it's been this empty. That's pretty wild. Oh man. Yeah. Very, very solid day for me. Oh, rank 4 and rank 2. Man. And I guess I didn't have any bugs, so that was pretty solid. I'm actually curious, were these lines necessary? Probably not. Maybe I probably wasted 5 seconds writing these lines, so maybe that would have, I wanted a utility of like min max, which just like does the min and the max, so that I could write this more easily, but I actually don't know if I wrote that in AOC tools or not. I don't think I did. Let's take a look. Min max. I never wrote it. Yeah. Okay. Well, good thing I didn't try and use it. Okay. Same answer. So yeah, this was completely unnecessary. I eyeballing the input and it didn't look necessary, but I was like not confident, and that would be a silly thing to get burned by. So I just wrote it just in case. Yeah. So I guess I could talk about the problem while leaderboard is still filling up here. So 22. Yeah, so basically the problem, as described, is we have a bunch of these like 3D bricks, And each of these bricks is like a 1 by 1 by some by k rectangular prism. Is that the right word? Well, anyways, it's like a bunch of blocks, and they can be in any orientation, and they basically give you like the locations of a bunch of these things at some point in time, and they're saying that they're all like falling. And this is sort of like Tetris style physics, where once something is resting on anything, even partially, it like solidifies, and you don't need to worry about like any weird gravity stuff. So they give you all these bricks, and the first thing basically says, suppose that all these bricks fall and they all settle into place. Which bricks can you remove without causing any other bricks to fall? So that's part one. And the first step here is like actually just simulating all the falling bricks. And I think that there's no like fancy algorithm here. You kind of just do it, but I guess it maybe takes a bit of thought. And the way you simulate it is or the way I simulated it is for each brick you have its range of coordinates. And since z is the upward direction, like z is the direction they're falling in, if you want to simulate it falling, you just decrease z by 1, and that's all you have to do. In order to check if it's supported or not, we just need to look at everything like beneath the face of the brick. So if a brick is going from 8.6 to 8.8 to so this is a brick that's extending out in the like y direction. We just need to check between 8.6 to and 8.8 to If any one of those is like a solid block, then this brick cannot fall. So that was what I wrote. This is solid. And initially I just sort of looped through all the other bricks to do this. This was not very efficient. So what I ended up doing is creating this set, B set, which sort of tracks the bricks we currently have that are, or it's just like a set of all the coordinates. One optimization you can make here is that you don't actually, for bricks that are vertically oriented, I'm trying to see if I can find one here. Like this one, 224 to 227. For bricks like this, you actually only ever need to so B set is the thing we're going to use to check collisions. You only ever need to record the top coordinate 227, because nothing could collide with 7.4, 224, because if so, it would have collided with 7.4, 225, and 6 and 7. And these bricks can't overlap. So that's one minor optimization to make. I don't think it's probably not necessary. It'll just be a little slower if you don't make it. Similarly, when you're checking every grid cell beneath a block to see if it's supported anywhere, that's what this does. You only need to check the low z. So we don't need to check one coordinate below this. We only need to check one coordinate below this, because that's the bottom of the brick. So yeah, just another minor optimization. Because each brick is one-dimensional in a sense, I think it probably won't really matter even if I didn't make that optimization. It'd probably be almost as fast. But yeah, that's a minor thing. But yeah, so first I simulate all the bricks falling. And one thing to note is that depending on the processing order, it is possible that bricks will fall in a very weird way here. So if I have a brick that is like this, and I have another brick that is like this, and there's some space, and the floor is here. If I process BBB first, and then if I process the B brick first, I'll probably make the B brick fall, and then later I'll see the A brick, and I'll make the A brick fall, and all will be good. But there's a chance with my current thing that we process A brick first, and we're oh, A brick can't fall because the B brick is here. This doesn't really matter. There's nothing that says we need to simulate in a good order. So it's completely fine if the first tick we make the B brick fall and the A brick doesn't move, and then the next tick we realize, oh, A brick is not supported, and then the A brick falls. This could be a little inefficient, so it's not ideal, but it doesn't really matter for something like this input. So yeah, I guess that's not really an optimization, but it lets you avoid thinking about annoying update order logic. I guess you could probably also just sort by z coordinate, and that would have the same effect. Or like that would cause you to always update in the right order. Would it? I mean, I'm trying to think, because you can have weird things where you have like one brick and then two vertical bricks, and maybe the ordering matters there. I think you could probably do it, but again, I don't think it matters. You can just update in any order. But yeah, and then I kept track of this Boolean fell, which sort of tells us has any brick moved locations. And then at the end, what did I write for this initially? Oh, initially I basically just shove this all in a function, and for each brick, what I did was I tried deleting that brick, so literally like copying the bricks and deleting it, and then just seeing if bfall was so here, like I can rewrite part one, and just seeing if my fall function, so this does one step of falling, seeing if my fall function, if the fell variable was true, because if it was, that means the things fell. So I don't think there's any like special sophistication in my solution here. This is just sort of a solid, I wrote it fast, and I wrote it bug free, and that was the key here. Cool, I guess solution's still coming in. But yeah, so part one, I think what I wrote was basically this. And then if b full, b copy 2, 0, this is fell. If something fell, or if nothing fell, then it's safe to delete this brick and cause nothing to fall. And that's part one. Let me. Oh yeah, I said it's 0. Okay, cool. I'm gonna get rid of this print. And then part 2 says, okay, well now the question is, if you delete a brick, it could cause any number of bricks to fall. Compute the number of bricks that would fall if you delete each brick here, and then add them all up. And once again, like I can just sort of use the function I've written. One nice thing. Oh, so one note to make here is you can't get away with just doing one step of bfall the way I've written it, because of the fact that the bricks could update in any order, and it could be the case that a brick doesn't fall the first time you call bfall, but it will fall the second time you call bfall. So this is why I simulate until everything stops falling. So this just like simulates deleting a brick, and then simulating all the bricks falling until everything settles. And then once that has happened, just look at the brick list and see which bricks are different. If the brick is different in any way, then it means that brick has fallen. And this uses the fact that my bfall function keeps bricks in the same order. So the same brick will appear in the same index of new bricks like later on. But yeah, and that was it. This should have worked. Yeah, 439 and 435.6. Cool. But yeah, that is all I have for day 22. I guess solution's still coming in, but I'm curious to see when I'm on the global leaderboard. Oh, I jumped up to number 10. That's cool, especially if I stay here. Who's behind me? Is it? It's just annoying to have to keep. I like to wait to check global until this is capped, so I don't see like some partial value. But I guess there's like still 60-ish points is the max number people could get. I think this person already solved. Yeah. Okay. So I guess my position is solid at 10 for tonight. Cool. That's exciting. It would be very exciting if I could finish in the top 10 this year. I think my highest ever finish was 2021 maybe, where I was 2020. Yeah, I guess it must have been 2020, right? Yeah, in 2020 I got 9th. How many points would I have been on track for? 37. I think probably a lot more than this year. So that would have been. I was getting like 123 points per day. Currently, we've had 22 days, so I would have been at 2704 to be on track. Oh wow, I'm like way down on track. That's pretty crazy. I guess maybe this year is more competitive, and fewer people have like points from every single day. Wow, and this is also without day 1 points. Yeah, I remember my personal times in 2020. I was like very consistent at leaderboarding. There were like only a few days where I didn't get points. So I guess AOC's has gotten a lot more competitive probably in some sense. That or I've gotten worse and so has everyone else, but that seems unlikely. Cool. Well, yeah, that is all I have for day 22 of Advent of Code. I will see you tomorrow.